Not that old. All right.
Good?
I hope so.
Awesome. Okay, guys. So I'm Mark. I'm going to talk to you guys about LEDs. I'll try to keep this brief because I know you guys are really anxious to get back to building stuff. So who here has worked with LEDs before in your starter kits? Pretty much everyone. Almost everyone. What did you guys use them for? Let's just shout out some stuff they were used for in your lighting. That's a good catch-all. Yeah, so you probably had a LED indicator, see if your device was on maybe, or the voice modulator had let you know that yes, it was picking up your voice. So stuff like that is good for LED, is what LEDs are commonly used for. Here we have a few examples of what LEDs are. Anyone know what LED stands for? Probably has. Okay, let's together.
Light emitting diode.
Light emitting diode. That's good. So an LED is a diode that emits light. What the heck is a diode? I like to think of diodes as one-way wires. To a vague approximation, that's pretty true. Essentially, a diode, symbolized by this, the arrow, the fast forward button, or jump ahead. It's a P-type material and an N-type material. What that means is one is positive, one's negative, and when you put a battery the right way to it, they get pushed together and current flows. When you put a battery the wrong way to it, they repel and the depletion zone gets bigger and nothing goes through. So that's the general way of how the diodes work. Diodes are used for indicators, energy efficient lighting, displays, stuff like that. You guys are probably going to mostly be using them for indicators or any other uses you guys have for them in your main projects?
Flashlight.
Flashlight. That's very energy efficient. So yeah, they draw a lot less power than compact fluorescence or incandescents. So they're really useful for energy efficient lighting. So important values. If you're looking at an LED or a diode, you're going to probably see a graph like this in the manual. And it's very good to know what all this means. So in this, there are three main regions. Past the 0.7, diode essentially just works as a wire. There's a little bit of a current of a voltage drop at the diode, but most of the current passes through, and you can treat it as a wire to a reasonable approximation. In here, in this region, in between the 0.7 and the breakdown, you get no current flowing through, or just a little this way and just a little that way. This is where there's not enough energy to push the two regions of the diode together. So you have essentially nothing going through except for a little bit in either side. Then there's the breakdown voltage. You want to avoid the breakdown voltage. This is the point where diodes break, in case that wasn't obvious. At that point, current's going to flow freely through it. Essentially, you just put a high enough voltage in the wrong way, and current ends up flowing freely through it. And you probably are going to need a new LED or a new diode. Yeah, so here, this is the diode drop, and it's important to realize that that is going to happen if you put a diode in your circuit. Yeah, so for more information all about circuits, does anyone have any questions? Yeah. Yeah.
When you said that like voltage or a current won't run through it at a certain voltage, is that different for different diodes?
Yeah, generally there are two types of diodes. There's silicon and germanium, yeah. Silicon's about a 0.7 and germanium's about a 0.3 volt drop. But each diode is slightly different. Yeah.
What did the I stand for on the graph?
Current,
Okay.
yeah.
On my starter project, I had like a Zen diode or something,
How's that?
and when I looked it up online, it said it was like an ideal diode. Like, what does that do that's different from like other diodes?
And the diodes are,
In this case, we're talking about LEDs. LEDs are a little different than Zener diodes, and the other diodes that you're dealing with, Zener diodes are going to be used in, like, let's say, in the case of like voltage regulation. That's significantly different than light emitting diodes. So then Zener diodes you'll be able to like regulate voltage with. Light emitting diodes, they both have the idea that current only flows in one direction. But in the case of light emitting diodes, this is just emits light. Zener diode, you have the ability to use that to control voltage or control current.
So then could I like control diodes for when it should let current through and not through at all? Is there any possible way to control that?
I'm sorry, I don't follow.
Like when to just not let any current through and when to let current through?
Yeah, you usually do that using this graph.
Oh, okay.
Yeah, you manipulate the
Okay.
circuitry in that way. Yeah.
Questions, comments, concerns?
Yeah. But I do recommend, if you have like obscure questions or really want to get a good thing, allaboutcircuits.com is the best website I've seen for like in-depth knowledge of circuits, and it's pretty accessible. So.